Alright, so in this video, I'm going to be solving the equation a to the power of 4 is equal to a minus 1 to the power of 4. So to solve this, my only variable in this equation is a, which is the variable I'm going to be solving for. And now for my solution, I'm going to first rewrite this problem down here so I have a little more solving space. So my problem is a to the power of 4 is equal to a minus 1 to the power of 4. Now from here, I'm going to subtract a minus 1 to the power of 4 on both sides. So then these two cancel out, and I get a to the power of 4 minus a minus 1 to the power of 4 is equal to 0. Now, from here, I'm going to rewrite a to the power of 4 as a to the power of 2 times 2. And I'm going to rewrite a minus 1 to the power of 4 as a minus 1 to the power of 2 times 2. And the reason I did this is because if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So a to the power of 2 times 2, I can rewrite that as a to the power of 2 to the power of 2. And a minus 1 to the power of 2 times 2, I can do the same thing. I can rewrite this as a minus 1 to the power of 2 to the power of 2, and this is equal to 0. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So, in this case, I can think of x as a squared and y as a minus 1 squared. So by using this property, I get a squared minus a minus 1 squared times a squared plus a minus 1 squared. And this is all equal to 0. Now, we're going to go ahead and expand a minus 1 squared. So a minus 1 squared is the same thing as a minus 1 times a minus 1, which is equal to, I can distribute the a squared minus a. Now if I distribute the negative 1, minus a plus 1, which is equal to a squared minus 2a plus 1. So now I get a squared minus 2a plus 1. And then I have this times a squared plus a squared minus 2a plus 1 is equal to 0. Now for my left-hand side, these two cancel out, and all I'm left with is negative 2a plus 1. And for my right-hand side, these two add, a squared plus a squared, so I get 2a squared minus 2a plus 1, and this is equal to 0. So, now from here, what I'm going to do is divide this into two different equations. So my first equation is negative 2a plus 1 is equal to 0. And my second equation is 2a squared minus 2a plus 1 is equal to 0. Because either of these, just one of these needs to equal to 0 for the entire equation to be equal to 0. So now I'm going to solve each of these equations individually. For negative 2a plus 1 equals 0, all I have to do is add 2a on both sides, and I get 2a is equal to 1. Now, if I divide both sides by 2, these two cancel out, and I get a is equal to 1/2. So this is one solution for a. Now, for 2a squared minus 2a plus 1, what I'm going to be using to solve this is the quadratic formula, because this is a quadratic equation. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 2, b is negative 2, and c is 1. So I plug these values in, I get negative of negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 2, times c, which is 1, all over 2a, so 2 times 2. And now this is equal to positive 2 plus or minus the square root of 4 minus 8 over 4, which is equal to 2 plus or minus the square root of negative 4 over 4. So now the square root of negative 4, I can rewrite that as the square root of 4 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I get a equals 2 plus or minus the square root of 4i over 4. And the square root of 4 is 2. So I get a equals 2 plus or minus 2i over 4, which simplifies to a equals 1 plus or minus I over 2. So this is another 2 solutions to my equation. And finally, just to check, I can't check the imaginary solutions, but I can check 1/2. So I have a to the power 4 is equal to a minus 1 to the power 4. A is 1/2, so I get 1/2 to the power 4 is equal to negative 1/2 to the power 4. And both of these equal 1 over 16. So this is right, and my solution is right. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side. Because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, well, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equals 250, and just at first glance of this equation, we can tell that x is not going to be a whole number because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now, to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now, I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front, and I have log 5 to the power of 2, so I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143, so I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right.